For example 2, we're given the graph of f prime. So f prime specifically is made of two line segments and a semicircle, and then this is the only piece of information that I'm given about f. So these questions are asking me about the actual position of the function at specific x values. So with knowing that, we know we want to integrate because we're going from f prime to our original f function. What gets us here is that we have to actually apply the fundamental theorem of calculus. So if I'm trying to find f of 0 and I know information about f of -2, I want to make sure that I integrate using these as my limits of integration. So I'm going to always go from left to right. So I'm going to go from -2 to 0 here. And I am integrating f prime. But the result of that is actually going to give me f of b, which is the 0, minus f of a, which is the -2. Now focus on this because what I'm trying to find is f of 0. So if this is the piece that I'm trying to find, you have to actually add this piece to the other side. So we're going to add that part over. So we're going to say f of 0 is equal to f of -2 plus the integral, which is the displacement between -2 and 0. So the amount of change. So this is where we become a little bit of calculus still, but mostly algebra students, because I know that to integrate from -2 to 0 is going to require that I look directly at this triangle here. This is all above the x-axis, and I'm going from -2 to 0, so that's going to give me a base and a height of that triangle. So I'm going to say f of 0 equals 5 plus 1/2. Base is 2, height is 4, which ends up yielding 9. So this is the value at f of 0. So the idea is that I started at f of -2, and then I moved positively 4 units, and that's where I landed at the 9. So now let's do the same thing for 2. Now, knowing this, I could, don't have to, but I could start at 0, but because I was given this information, if I made any error here at the f of 0 value, then obviously this one would be wrong if I used this. So I always go back to the original piece. So I'm gonna move down just a hair. So we're actually gonna integrate from -2 to 2. We're integrating f prime. It's just an arrow. It doesn't really look like an arrow, does it? Equals, and we're going to do f of 2 minus f of -2. Nope, I don't want the equal sign there. So now I'm going to rewrite as f of -2 equals, I'm going to move that f of -2 over, f of -2 plus, and then I'm going to find some area here. So the area from -2 to 2 is this whole triangle. So I'm still going to do 1/2 base times height, but my base is now 4. So that becomes 5 plus h, which is 13. Okay, so this right here ends up being 8. So this is applications of the fundamental theorem. So let's do the last one here. So now I'm going to go all the way to 6. So again, I'm going to do integral from from -2, to 6 of f prime of x dx, because I always want to use what was given, equals f of 6 minus f of -2. So now I'm going to move that part over. So I'm going to trying to solve for f of 6. So I'm going to say f of 6 equals f of -2 plus the integral from -2 to 6 of f prime of x dx. So I already have f of -2 is 5, and now I have to do the area part. This is where you have to use your knowledge of integration and know that this triangle is positive, but this semicircle is actually going to have a negative area to it. So I'm looking at all of this as one area, but I'm going to do 1/2 base times height, which I know is going to be 8. But then I'm actually going to subtract. So I'm going to subtract the area of the semicircle. So the formula for area of a semicircle is pi r squared, but I'm going to do half of that since it's a semicircle, pi, and then the r is 2. So we'll do 5 plus 8, but then we're actually going to subtract. This is 1/2 pi times 4, which becomes 2 pi. That's where we get 13 minus 2 pi for the area. Sorry, this area here. And so my actual value for f of 6 is given by 13 minus 2 pi.